Alright, this is notes for geometry, notes 4.7, notes number 28, isosceles triangles, and I forgot to put essential questions, so don't worry about it. This one's easier than any we've done this chapter. This is theorem 4748, base angle theorem, says two sides of a triangle are congruent and the angles opposite are congruent. So when it says that the sides are congruent, that means the angles are congruent as well. So that means angle B will be congruent to angle C. And then the reverse, the converse, is on the next one. This says if the angles are congruent, then the sides opposite of that angle that's directly across will be congruent to each other. So these go back and forth. So it says AB will be congruent to AC. That's a nice thing about isosceles triangles, is the legs are equal as well as the base angles. Those are equal to each other. So when you go to your example, it says in triangle FGH, FH is congruent to JH, and there is a little line above it. I don't know if you can see them, but those are segments. It says name two congruent angles. Well, GH across from it would be angle F. It'll be congruent to the other side, FH. The opposite angle is G, and those are going to be your base angles. Okay, on the corollary, it says to the base angles theorem, a triangle is equilateral, then it is also going to be called equiangular, and you can see it in the little bullet to the side, equiangular, how to spell it. Which basically, equilateral means all sides congruent, and then equiangular means all angles are congruent. Which you guys have told me that you knew this, so this is nothing new. The second corollary is just the opposite. It says if a triangle is equiangular, then it is also going to be equilateral. It means it just goes both ways. And realize an equiangular or equilateral triangle is also called isosceles, because at least isosceles, at least two sides are congruent. On the back sign it says, okay, if the measure, find the measure of the angles if you have a equilateral triangle. Remember, all of the angles of a triangle add to a total of 360 degrees. So if I divide that by 3, oh, I'm sorry, that's a circle. That'd be 180 divided by 3. That means each one is 60 degrees. So that means angle R is, the measure of angle R is going to equal the measure of angle S, which equals the measure of angle T, which all equal 60 degrees. Okay. On number 3, it says find the value of X and Y in the diagram. If I'm looking at my picture, I'm looking at what is given to me. I see that K, L, and J are all equal, so that means all the sides are equal. So if this side is 8, that means this bottom edge is also 8, so I know X is equal to 8. And then if I look at this little side here, it tells me that this is isosceles. So that means this side is equal to that side. But to find y, I have to set up my equation. So I'll have 8 equals 2y. Divide by 2, and y is equal to 4. There's my two answers. Okay. Alright, apparently this was from another note, so don't worry about your summary down there at the bottom. This note does not have any proofs as far as I know, so this should be an easier lesson for you.